Sorry that took so long to deal with. For their homework. Alright, so finally our line of best fit notes. Okay, so linear equations are often used to model real-life data. And so, again, like we looked at with the social media influencer. And today we're going to investigate some of those relationships. And so what we have here are scatter plots. So a scatter plot is a visual representation of a data set, meaning we take the information, put it on a graph, and we see these dots. All right, the correlation, I spell around two R's, two O's, twisters. The correlation describes the relationship between data points, and it's similar to our slope. So like I said, if we were to approximate our line of best fit, so our first one here, if you were to just draw an approximate line through the middle of these points, we can see that it's going up. This is a positive correlation. Does anyone want to share one of their examples of a positive correlation? Angela?
Your height over time.
Good, good. Height. Is it right if I say height versus age, maybe?
Mm-hmm.
The height versus age. So the older you get, the more you grow. Obviously, to a certain extent, it might level off, but at least in those childhood years, as you get older, the more you grow. Good. All right, now our middle one here, if I were to draw a line kind of through the middle of these data points, we can see this is a negative correlation. So it's going down, and the example I said is the more money I spend, the less I have. What are some other examples? Andrew?
I was gonna say something, but I feel like I shouldn't say it.
That's probably a good choice. Gabby? Ooh, I like that one. Gabby, you're nailing it with some good examples today. So Gabby said the more you run, the less energy you have.
She's smarter than you.
That.
That's something you would say in biology, not algebra.
No, that's a perfect example for a negative correlation. The more you run, the less energy you have. Other thoughts with a negative correlation. Sometimes I think this one's a little hard to think of. Yes, Andrew.
Amount of relationship you've had.
Amount of relationships you have versus what?
Amount that succeeded.
Okay. So relationships you've had
Last one.
versus success or continued ones. That could be a negative correlation. It could be a no correlation, could be a positive correlation. So it could be, depending upon the person, it might be in any of those. Another negative correlation could be phone use versus battery power, right? Battery life. So phone use versus battery.
I feel like you're using that against us.
No, it just is another negative correlation.
That thing I'm trying to.
When you use your phone more, what happens to your battery?
It goes
It goes down. I see it every day from you guys. All right, and then no correlation. What are some examples of things that have absolutely no relationship whatsoever? What's the no correlation ones? Yes, Andrew.
Amount of children someone can have.
Versus.
The less.
Amount that they're not going to have.
What we want something that has absolutely no
Oh, so like
correlation.
children you have versus like.
Well, let's take the number of children. All right, give me something that has absolutely nothing to do with the number of children. Versus number of cats. Good. What's another no correlation? Yes, Andrew.
Amount of money versus like I don't know.
Shoe size.
Yes.
How about that?
Good.
Good. So I'm going to say salary versus shoe size. Good. So these are some things where if we were to plot that information, if I were to take each of your shoe sizes and find out how much money do you have, even just on you, there's probably no correlation between your shoe size and how much money you have. So you can see it's all over this is our no correlation. Okay, so we've dealt with our scatter plots before. But today what we're doing is we're taking it a little bit further and doing line of best fit. Sorry. We'll go back.
Okay, go ahead.
Here we go. Okay, so I've already talked about this a little bit, but what we have today is our line of best fit, and we're going to be using Desmos to help us out with that. So a line of best fit, is basically what it says. It's a line that best fits the data. It's a straight line that best represents the data of the scatter plot. So it's kind of, if you can approximate it in the middle of all your dots there. To estimate the line of best fit given a graph, we can sketch a line that comes as close to the pattern as possible. All right, we then find our slope, and that's our end value. We find our y-intercept, and that's our v-value. And we write our equation in slope-intercept form. So we're still just writing the equation of a line. It's just now we have to do some work to find our slope and y-intercept. So remember, our slope-intercept form is y equals mx plus b. Okay, so for our graph here, you can either do it on the little graph that's in your notes or on our warm-up, right? We have the bigger version of the graph. But go ahead and just do your best of a general sketch. Draw a line of best fit that kind of goes in the middle-ish of these points. Yours might be a little different than the person next to you, but they should be all about the same general region there. So go ahead and draw a line that's kind of in the middle of all those points. We're not connecting the points, just kind of in the middle of it. All right, and then I want you to hold up your notes so I can see your line of best fit. Good. I need some line of best fits in this row here. Jonathan, draw your line and show me. Alejandra, good. Alan, can I see your line of best fit? Alan, draw a line and show me. Ben, that looks good.
It's not that hard
Omar?
to draw a line.
Good. Bradley, that looks wonderful. Angelica? Thank you.
Making sure they're not.
All right, Alan, let me see it. That looks wonderful.
No knowledge allowed.
Good, good, good. Alessandra, good. Rodrigo, trying to draw a line through those. Those look good. Anthony, good. Emma, draw a line. So we want it to go kind of through the points. Katia looks good. Me and I didn't see yours. I'm sorry. Joy and I didn't see yours either. Good. Good. And Marjorie? Emma, that looks good. Good. Rodrigo, that looks good. Awesome. All right. So I'm going to go ahead and draw a line. Now to make this next part a little bit easier, I'm going to draw a strategic line here. But perhaps we have something like this. Okay. Now this actual line of best fit might be a little off. Like it might be a little more slanted or whatnot. But the reason why I chose this one is because it's going to be a little bit easier for us to write the line of best fit for this graph. So we're just going to get a rough estimate, right? And then we'll use Desmos to get the actual answer here. So what could be the line of best fit for this graph? Well, remember, think back to y equals mx plus b. On the one that I've drawn here, what is my y-intercept?
I have no idea.
What's my y-intercept? 0. Yeah, it goes to the origin, right? So I have for this one that my y-intercept is 0. Now to find my slope, I'd have to do rise over run. And so I see that I went through a couple different points here.
3.
And so I could use any of those. Now, take a look at yours. Let me see if we have the data here with it.
What are you gonna do?
Okay. On the actual warm-up that we did, I'm going to borrow Andrew's.
Yes.
On the actual warm-up that we did, oh, it doesn't have the data for you down there. Right, that's right. Let's take a look. Okay, so we can approximate our slope here. Now, again, your graph might be a little different than mine, but I want you to go ahead and approximate your slope. So remember, we're just counting rise over run. And if you didn't go through any two specific points, that's fine. If I take a look at the ones that I have here, I'm just going to take a look at these two. And again, I'm just getting an idea, an approximation. I see that this is at, let's see, 10, 20. This is at 20. 30, 40. This is at 40. This is at, let's see, that's 100. So it's 20, 40, 60, 80. So this is at 20. Oh, no, that's at 40, sorry. So we have 20, 40, 60, 80. Okay, so if I do my slope equation here, my y value, 80, minus my y value, 40, over my x value, so I did the top one first, so 40, over my x value, 20. Alright, so I get 40 over 20. What's 40 divided by 20 give us?
20.
2. Good. So for this particular line, my equation would be y equals my slope, which is 2, x, plus 0, so that's really just saying y equals 2x. Now, for our problem right here, my line of best fit that I drew went through those points nicely. But if it doesn't go through the points nicely, it's kind of hard to figure out that slope. And so that's why we use Desmos. Desmos will find the actual perfect line of best fit. Now we can do this by hand. You would not be happy if I made you do this by hand. It's a bit of a lengthy process. But there is a formula behind how you find it. But Desmos does that math for us. So what we're going to do is we're going to use Desmos, we're going to enter in all of our data, and then we're going to use Desmos to figure out that equation plan there. Okay. Now we can also use our line of best fit to make predictions about the data. So let's say, for example, how much money will someone with 200,000 followers make for one Instagram post? Okay. So let's take a look. Our number of followers, that was X. The amount, that was our Y, right? So if we have our equation, Y equals 2X plus 0, so Y equals 2X. How much money will someone with 200,000 followers make? So 200,000 followers, is that my X value or my Y value? X, yeah. So what we're saying is when X is 200, how much is Y? Okay, well we just put into our equation. So I get Y equals 2 times 200. So with 200 followers, approximately how much would we expect to make? 400, and if we look, Y is measured in thousands of dollars, so $400,000.
What?
Now, we don't know that's the exact amount, but it's a prediction based upon the trend we see from the data. Alright.
Wait, bar graph.
Yes, if you go.
That is wrong because it'd be 200 million for 400,000.
Oh, you're right. That should say 200 million. I apologize. Thank you. Sorry, guys. In your notes, our followers was measured in millions. That is very important that Andrew caught that note there. 200,000 followers would not give you very much. That'd be like 0.2. So, gotta have a lot more followers. Okay. So, again, we can use this to make predictions. Now go ahead and flip your notes over to the back side there. So we're pausing with our social media influencer. We're going to take a look at some other examples. So here it says, which equation could be, or best represents the data shown in the sketch? Okay. So if we were to draw an approximate line of best fit, just do your best to draw, and then you think it kind of goes through the middle of it all. Which of these equations would be most likely to, of these four, which one best represents the data? So first of all, let's take a look at our line. Is this a positive slope or a negative slope? Negative slope, good. So we can automatically throw out B and D. Okay, so we said our slope is negative. Now let's take a look at our y-intercept, our B value. If I take a look at my options that are left, I have either B value of 9 or B value of 0. Which one matches up with my graph here?
Oh, wait.
Where's my y-intercept? It's going to be higher up, right? It's certainly not 0. It's up here at 9. So that allows us to then know that A is going to be our answer right now. Now, we don't know the exact equation, but of these four, this would be the best fit for it. All right, let's take a look at the one next to it. So based on the scatter plot, what is your exam score if you missed 15 classes? Okay, so let's go ahead and begin and draw an approximate line of best fit here. Whew. Okay, that's not very good, but we're working with the smart board that's a bit wonky here.
Maybe you should get it fit.
Yeah, wouldn't that be great? They've tried.
Just get a new one.
Yeah, they don't have those.
Okay, so it says based on the scatter plot, what is your exam score if you missed 15 classes? So 15 classes, is that going to be my x value or my y value?
X.
Yeah, the number of classes missed is x. So we're saying when x is 15, what does y equal? So if I go to where it's about 15, right about here-ish, looking up whichever answers best fits that.
A.
So if we take a look, as we go up, kind of match it up on your graph. It might be easier for you to see it on your paper and rather than me up here on the smart board. But x is 15, so about halfway in between. Here.
Also C.
Looks to be about 60-ish. 41 is a little low for it. 20 is definitely way too low. And 82 seems a little too high for it.
So C.
So I would go with C. Good. And you are always welcome, if you ever need to borrow a ruler, you're welcome to do so. On the SOL, they'll have a ruler for you too. Sometimes it's a little bit easier. Or you can just lay your pencil flat to make it parallel to that line there to kind of see. But good. So at 15, we kind of go up, go over-ish. It might not be exactly 60, but it's an approximation of it. And so this would be an example of that negative correlation. The number of classes you miss versus how well you do in a class. If you're not there, you can't learn. Okay, so now we're going to take a look at how to actually find the line of best fit, like the actual equation for it. So now you do need your computers out for Desmos, so you can get out your laptops. If you don't have a laptop or you don't have a charged laptop, you can either use your phone or just watch what we're doing up here. But you'll be using this for your homework, so make sure you do have your laptop charged up. You lost your privileges, you're going to just have to watch what we're doing up here. So the first thing that I want you to do is to go to Blackboard. I've created a link for Desmos up on Blackboard. So it's a little bit easier for you to get to it. Yeah, so go to our actual Algebra 1 class. I'm going to bring it up here. So this is Algebra 1. All right. And so on our class, over here off to the side, I've added in, so over here is where course materials contains all of our information. Videos of lessons, that's the recordings of our lessons that I post on YouTube. Math Space, that's our resource for practice problems online textbook. I have now created this link called Desmos. So if you go ahead and click on that, this takes you to the Desmos graphing calculator. And this is specifically the one that you'll have for your SOL as well. They allow you to use Desmos on the SOL. So you'll notice it's Virginia, the SOL version. Once you've clicked on that, go ahead and click the little star that bookmarks it. So that way, you would have yours listed up here. I have a few too many bookmarks and lines listed on here. But that makes it a little bit easier for you to find it so you don't have to go to Blackboard every single time. The other thing, too, that you can do is that you can create a shortcut for it. So if you hit the three little dots, and then More Tools, and click Create Shortcut. What's that? Go to Blackboard and click on the Desmos link there. That'll take you to the proper one. When you create that shortcut, then this appears on your desktop and you can just click on it from there. So it makes it a little bit easier to get to. So either bookmark it or create the shortcut. Again, to create the shortcut, once you're on Desmos, so we've gone to Blackboard, we've clicked Desmos. When you're on there, then hit the 3 little dots, more tools, and click create shortcut, and that creates that little icon on your desktop so that you can easily get there. And you're welcome to use Desmos as you're doing your homework. You can use Desmos just as a normal calculator, like if you're wondering what's 82 divided by 6. Oh, hold on. Sorry, we're in the graphing calculator one. We don't want the graphing calculator one for that. Let's see. All right. For just the regular graphing calculator, just desmos.com/calculator, and that allows you to do just regular information, 82 divided by 6. And so you can use it as a regular calculator as well. Okay. So what we're focusing on is creating that equation, the line of best fit. So taking a look, what we want to do is first add a table. So on Desmos, I'm going to be going back and forth here. You click the plus, and it says table. So then click table. And it automatically fills in x1 and y1. So we are going to go ahead and fill in those values. So on our notes here, it says enter your data into the table. So the first one is always our x. The second one is always our y. So go ahead and enter in this data, and you'll see you enter all of your x's in for x1, and then enter in all your y's for y1. You can either just arrow down or hit enter. I want you to go ahead and enter in that data. And it's always good to do just a quick double check to make sure that you haven't mistyped something. Okay, so go ahead and type in that data. I'm going to do it up here. And you can either type just using your keyboard or type using numbers. I would recommend the keyboard though. So again, I'm just entering that data from our notes. So I've got all my x values, and I'm going to go back and fill in the y values. And then hold on just a second. So I should have the same number of x's as y's. And then get rid of this little keyboard. And then a really nice feature with this is that if you hit that magnifying glass, it'll automatically move your graph so you can see all the data points, rather than you kind of having to zoom in and out trying to figure out where to go. If you hit that little magnifying glass, it automatically changes it for you. So this is what we had on our social media influencer. This is that data. And we talked about how we can go ahead and draw that approximate line of best fit. So now, before we're just coming up with our own equation, our best guess for it. Now we're going to make Desmos actually do that for us. So go ahead and flip to your second page of notes. Okay, so we hit the magnifying glass. So next up, how do we find our equation of best fit, or line of best fit? Okay, so on Desmos, what we do now is we're going to, you can either hit enter to go to the next line, or you can hit the plus and choose expression. Either way, what we're going to do is we type in our standard form. Now, standard form is y equals mx plus b. But if you notice, when Desmos created this table for us, it says x1 and y1. So we're going to say x1 and y1 as well. So that's what it's saying on our notes there. Is we're going to type in, instead of y equals mx plus b, y1, little squiggle, mx1 plus b. So again, our original equation is y equals mx plus b. Because Desmos calls it y1 and x1, we want to say y1 and x1. And then to communicate to Desmos that we want it to do the equation for us, instead of doing the equals, we do this little squiggle or tilde thing. That's going to be on your keyboard up by the number 1. You have to hit shift and then that. Or you can go ahead on Desmos here in the keyboard. We have to go under functions, is it? Stab. Or they moved it. Where did they move it to? What does it say?
If you go under like ABC.
Oh, thank you, ABC. They used to have it in a different spot. And then we've got it down there. It's probably a lot easier just to type it on your keyboard, but if you're using your phone, you want to go ABC, and then it's there with that. Okay, so we're going to go ahead and just type in Y1. And you can literally just type Y1 and it automatically makes it that little one. And then our squiggle. M times X1 plus B. If you don't put the squiggle, then it's not going to calculate the graph for you. So when you say y equals mx plus b, they're going to be like, great, you're going to graph it for us. What do you want m to be? What do you want x to be? Here, we're saying, Desmos, I want you to calculate all of it. Do all the fancy math so that you can tell me what the equation is going to be. Because the table, Desmos labels it as x1 and y1, so we're telling Desmos we want to use those values there. Oh, you literally just type y and then number 1 and automatically change it for you. So you'll see this information pops up. Desmos just did a lot of math for you. And we can also see our equation or actual line popped up here. They also graphed it for you. So for right now, in Algebra 1, you can ignore this information here. I don't think it's going to let me cross down. The statistics, the R squared, the R, the residuals. For you, for right now, you don't need to worry about what that means. What we're looking at is they told us what slope is, and they told us what our B value is. Okay? So we see our slope is 1.8, and our B value, our y-intercept, is negative 2.8. We'll just round to the nearest 10. Okay, so it, again, told us what is our slope and what is our B value. So when we go to write our equation, so here, again, we can ignore this. We can ignore this information. But we're going to look only at what m and b are. So now we can write our equation. Y equals m. And we said to go to 2 decimal places. So we'll go 2 decimal places. So our m is 1.80. X plus our b value, which was negative 2.8, so minus 2.80. So instead of us guessing where the line is, Desmos just told us exactly where that perfect line is. And then we say, all right, Desmos, tell us all of the answers. And Desmos says, here you go. Here's your slope. Here's your b value. We just put it together in our equation. Okay, so again, we take our y equals mx plus b, and we replace the m that Desmos gave us and the b that Desmos gave us. So you have to remember to type in y1 squiggle and x1 plus b. But other than that, Desmos does everything for you. All right, questions with that? Now, like we said, sometimes we want to make a prediction. And these are common types of questions on the SOL and on our assessments. So when we want to make a prediction, we're going to add an expression or just arrow down. So we're going to do more on Desmos. So we just arrow down or add an expression. And then we have to enter in a little more information. So you're going to type either x equals or y equals, depending upon what question it's asking. And then you're just going to look to see where they intersect. What does that mean where lines intersect? What does that mean if they're intersecting?
They're going through each other.
Yeah, if we have our lines intersecting where they happen at the same point. All right, so question A says, how much money will, I should say will, someone with 200, and we said that should say million, because followers was measured in millions. with 200 million followers make for one Instagram post. So again, if we look at our data, X was followers, Y was the amount of money. I'm going to go ahead and copy that here so that it's easier to refer to. X equaled followers, Y equaled money. Okay, so here it says someone with 200 million followers. And we said that would be X equals 200. Okay, part B says, how many followers do I need to make $125,000? So we're talking about money here, so that's when Y equals 125. Okay, so to find out if X is 200, what does Y equal? We go to Desmos. We have X equals 200, so we're just going to type in here, X equals 200. And you'll notice it creates that line for us. So we just need to see where they intersect. And look at that. If you hover right over it, it tells you, all right, when X is 200, Y is 358.57. So we'll just go ahead and round to the nearest whole number here. So $359,000 is what we get for that. So Y equaled $359,000. And remember, the money was measured in thousands. That's how I need to put thousands on the end. So I just typed in X equal to 200. This is what I'm grabbing here. So I typed in X equal to 200, and then I look to see where it intersects there. All right, so now let's do our next one. I'm going to go ahead and get rid of my 200. I don't need that anymore. Our next one on our notes said, when we make $125,000 off one post, how many followers would that take? So we have Y equals 125, and we don't have to put the 1,000 because it's already measured in thousands. So Y equals 125,000. And it goes ahead and graphs that, and let's hover. And it looks like we would need about 71 million followers. So $125,000, 71 million followers.
How do you get that one?
It's a great question. So our XI would be, was it 71 million followers? Is it what? You just put your cursor over top of it, and it'll tell you what that intersection is. So like I literally move my cursor, and it tells you there. Okay. Questions with that? Okay. So for these last two questions here, again, the first column is X, the next one is Y. You just go through the same process. Put your X values and Y values in for Desmos. So I would, on my Desmos, I would go ahead and clear this out, and I would add in a new table. Let me clear that out. And so you would enter in your data that you see here, and then write the line of best fit. Again, you just simply pull that from whatever Desmos tells you here. And then same thing for our next question. So this is our X, this is our Y. And it says, what value best predicts the length of time it should take for Debbie's 6-year-old niece to run one lap? So they tell us the age, so we have X equals 6. That's what you type in to find out what Y equals. All right, so you'll be using Desmos for your homework, and you'll be using it for the mini quiz next class. So make sure you have a charged laptop for next class. Let me pass out your homework to you.
In 4 minutes.
In 4 minutes. I imagine it was more than 4 minutes.
No, it wasn't, because we had to run the entire time.
Because Alan Webb was the first high schooler to run a 4-minute mile.
Yeah, but it's for ROTC.
So either it wasn't a mile or it wasn't 4 minutes.
Well, that's what they told me. It was like 4 minutes and 37 seconds.
Was it a mile?
5.5 miles.
All right, so your homework is worksheet 11.
More work to burn.
And again, the Desmos link is up on Blackboard if you're doing this at home. So hopefully you did this shortcut and it's on your computer.
No.
Where you go? You're going to TA.